steam power plant. So that is the basic objective of the today's class. Now, steam formation. Let us try to understand the process of steam formation. For that, let me take an example wherein I am having ice at, let us say, -7 degrees centigrade. What will happen if I add heat to it? So quite obviously anybody can say that its temperature will increase. Once it has reached to the temperature of 0 degree centigrade, provided we are working at atmospheric pressure. Thereafter, if you keep on adding heat to it, that is, this axis represents temperature and this axis represents the amount of heat that I am adding. Now, once I reach the level of 0 degree centigrade, and thereafter I can observe here that without changing phase, the temperature will not increase. That is, I'll have to add heat to some extent till it converts into liquid phase. So here I am having a solid phase and here I'll be having liquid. So in between you will be having mix of solid plus liquid. Once the complete amount of substance has changed into liquid, thereafter if you keep on adding heat to it, what will happen? The temperature will again start rising, and there is a limit to it also. What is the limit? Limit is defined as the saturation temperature of that particular fluid. In this case we are discussing about water. So what do we understand by saturation state? It depends upon, it is one of the properties of the substance which is related to its pressure. पानी कितने डिग्री सेंटीग्रेड पे बॉयल होता है, तो जनरली द आंसर कम्स लाइक इट इज 100 डिग्री सेंटीग्रेड, बट इट्स नॉट द ट्रू केस ऑलवेज. सो आप लोगों ने सबने कोल्ड ड्रिंक वगैरह पिया होगा, ठीक है. जब हम स्ट्रॉ से कोल्ड ड्रिंक को पीते हैं तो एक बार आप थोड़ा सा इमेजिन करने की कोशिश कीजिएगा कि हमने कोल्ड ड्रिंक को में जस्ट उसको थोड़ा सा स्ट्रॉ से सक किया है और वापस रिलीज कर दिया है. तो उस वक्त हम देखते हैं कि जो स्ट्रॉ है उसके चारों तरफ थोड़ा सा भाप वगैरह हो जाता है. व्हाट इज दैट? वी डू नॉट हैव 100 डिग्री सेंटीग्रेड टेम्परेचर नाउ. सो what will happen then? Because when I sucked it, I created a low pressure condition over there. So because of that low pressure condition, the boiling temperature of the substance, that is water in this case, has reduced, and because of that only the vapor formation happened with the water. So you can, that haziness that you look around the straw is nothing but the formation of vapor at some reduced pressure level. So maybe the temperature was around 20 degrees centigrade and still there was vaporization. So here what will happen is it will start vaporizing. So here I am having liquid only, and here it will be completely converted into vapors. Now once it has completely converted into vapors and I still add heat to it, then again I can see that its temperature will keep on increasing till I keep on adding heat to it. So now once this was the case, let us say we have some increased level of pressure. So if I increase the pressure and simulate this thing again, I will see that the temperature at which it started boiling earlier on will now increase. That is, I increase. Let us say I was working on atmospheric pressure, but now I'll be working at, let's say, 2 bar. So I will be able to appreciate that this line will be followed till this point and it will go like this. Once it has completely converted into vapors, again if you add heat to it, like this. So this is the point where the vaporization starts and this is the point where it completes. So this process is my phase change process. This is vaporization. But you can see here that I had drawn this line for lower pressure, a bit longer one as compared to the one at the higher pressure. So what will happen if I further increase the pressure? So in that case I'll see the line like this. Further increment of pressure will result into something of this kind. What if I lower the pressure? I'll see that it goes like this. It goes like this. So since the phase change process is reducing as you keep on going earlier, so it will result into a single point. It will result into a single point as you keep on increasing the pressure, and that pressure at which it terminates into a single point, that is called as critical point. Critical point. Now I am going to do one thing. I will be joining all the points at which the vaporization started, by a single line, and all such points at which it completed the phase change, that is the complete liquid was converted into vapors. So I get something of shape of a bell shaped curve, that is nothing but the saturation curve. This is a saturation curve, and the line to the left of this bell shaped curve, that is called as saturated liquid line, and the one to the right is called as saturated vapor line. So this is saturated liquid line, and this one is saturated vapor line. Stop.